Welcome, I'm Bill Wake. We're here working on a calculator to work with kilts, and we've done a lot of that, kind of two-thirds-ish, but one of the things we paused after finishing that second piece is that we'd like to upgrade our EGTest test framework. So I've created this parameterized testing framework, and as we were working, we built some extensions to it. Okay, and we want to make those extensions and fold them into the official release. All right, let's run the tests. I think we should have failing tests is what I recall. Okay, so test can't start with slash is not equal X. Yeah, that's true. Oh, is it there yet? Okay, so I don't know. I think I was confused yesterday that it looked like this one got caught and this one got caught, but it's not clear to me that this one got caught. But I actually think it maybe is. Let's comment out this much. All right, we'll do this test again. It's the only failing one. Okay, so I'm thinking maybe it's okay. All right, and let's comment out this one. Oh, well, one thing is the line number is, this one doesn't explicitly give the line number, so it's going to report it here, which is that one. So I think maybe we are okay. All right, yeah, I guess it was just end of day dullness or something. Okay, so I believe we now have EGAssert equal working, which means, well, really this EGAssert throws appears to be working. Okay, now as I look at it, and I'm trying to decide, is it worth it? Okay, the comparison point is this one, and well, I guess this was expected, is the expected string, actual is the actual. Okay, yeah, that kind of makes sense. All right, so what you're saving is, well, this line has to be the same because it's the one doing the work. Instead of expected file and line, we're getting just $0, and then instead of this function, well, and this line, capturing it, we're calling this function. Now, this function is awkward. It's maybe a name for it. It's a function that returns a function. Okay, so it takes an argument, and then it yields back a function of one argument. All right, and partly that's the way this needs to be, is it needs a function of one argument. So we created one here. But I believe we can switch this to be a function of two arguments and then let the framework build the inner function. Okay, let EGTest build it. All right, so yeah, I don't know. Could have been here 10 minutes earlier at the end of the day yesterday with a little more awareness, I guess. All right, let me take this out just to keep the comparison fair. All right, and at this point, I want to do this in the EG library. So the only thing I think I'm going to take over, well, I'll probably peek, but I think we'll start with this. Well, with that. And even that's, I'm kind of cheating, aren't I? EGAssert. Well, this is another public function, and we'll just do nothing for now. I'm kind of cheating on the test, I'll admit it. All right, so before the all pairs, all right, let's do our test assert throws. Okay, so func test assert throws when not thrown. Assert throws fails when nothing thrown. Well, it's not really nothing. Okay, so we're going to call, well, the heart of it is going to be EGAssertThrowsError of some expression and some example and some, well, we're not going to worry with this function yet. Okay, so the code, whoops, there's nothing to an ignored type. Okay, so the code, whoops. We got to do something. It's not going to throw. And we need an example. Input. Let's ignore it. And then the example, well, input is ignored. Expect output. Well, this is going to be the throw message. Okay. Okay, we'd like to be able to ignore it. Let's ignore it. Okay, so error to void, well, equals nothing in. Right now that's example goes to, and then we want something that's like error in. Okay, I think that does it. So it gives us a function that takes something, an example, and ignores it. It returns a function that takes an error, ignoring it, and returning nothing. Okay, so I think that's a valid result. Okay, now let's... to infer type of closure. Well, interesting. It's an auto closure throwing ignored expression. Oh, maybe we don't need that. Let's just do this then. It gets no arguments. Okay. Yeah. All right. And this should fail. And we're going to have to do this little expect failure trick. Wait. Did you really run? Why did you work? Oh, because our code doesn't do anything. All right. So it's going to have to call EGTAssertThrowsError on our expression. And, well, optional message file line and error handler. Example.message. Okay. Something, okay. Expression, message, error handler. Okay. Oh, wait, I know what I did. This test should throw, so if it doesn't, should have thrown. Well, it's not that it should have thrown. It should have an error. For an error. Okay, now this test fails. I hope. Thank you. Should report an error, but none recorded. Okay, now I can try this. I'll say throws error. Takes the expression. Non-escaping parameter may allow it to escape. Non-escaping parameter. I guess I got to say escaping. Doesn't offer to fix it. Okay. Expression. Example message. Okay. Which we didn't even use. File and line. Okay. I think this should pass now. Okay, it gives a little warning message. Did not throw an error. Okay. Okay, next test. I guess we want to do it succeeds. When error is thrown. I don't know if I can. I don't know if I can do this. Yeah. Okay, let's make a little helper. Okay, ignored, expect. Unused. Okay, so if you try to throw an error and, well, I guess we never even look at the example. We just throw it. this thing captures this, well, it calls XCT, which captures it, checks that it's thrown, and succeeds. So this test should just pass, I think. What do I know? Okay. Did not throw an error. I guess I'm going to step in. Am I supposed to evaluate expression? I bet I am. Yep. Okay, let's... Now, back in the day, the right compiler, you could just continue from here, but we can't. Okay, I'll try this again. Oh, that's a good point. I might have to do a try in here too. Not through an error. No calls to throwing functions occur within the try expression. Well, okay. Actually, I want to stop here. Why does it not catch it or throw it? Let me play around a little, I guess. This should just blow out right away. Let's make sure this is... So maybe my little bundle thing didn't do that. Okay. Okay, now I want to get the error handler going. So let's make sure the null case works for it. Of example. And those two tests should still pass. Good. I'm always just paranoid about them. Okay. Good. All right, now. Okay, this is one of these. Is it? Yes. Okay, so we're going to pass the function in. Well, now I want to change my function, so let's do that. Let's take example and, well, should we take the error first? We'll take the example and the error in. Okay. Let actual message equals error as string. Okay. And well, we can use EG. Okay. EG has no member expected. Oh, it's called expect. Can I convert a value of string to expected argument type? EGAssert equals. Actual message better be a string. I don't know if that's redundant. Example, error. Oh, yeah, they don't match my types. Okay, okay. Let's change this. Okay, so I think instead of EG, it should be EG and error. Goes to void, goes to nothing. Nothing in that. Not quite right. Can I use default expression for inference of EG input expected any error void because it's inferable from parameters 1 and 2? Wow, I don't know what that means. Okay, well, we will call error handler with expected and error. Well, we won't call exactly that. Let's see. Let's get this right first. Okay, so this thing cannot use default expression for inference of expected error goes to void. Error. Because it is inferable from parameters 1 and 2. Let's make this I guess it's saying it's still an error. Okay, so I'm trying to define a function that takes two arguments, some input, some expected, which matches all that stuff. And then I'm going to call it, I don't know, maybe I have to parenthesize this. Cannot use default expression for inference. Any error goes to void. Is that any of the problem? They don't like inferral? Oh, this would really suck. Switch to an existential. Identifiable of Swift.identifiable. I wonder if it's the any error thing. Try to make it generic. How is it inferable from parameters 1 and 2? Which ones are 1 and 2 even? Can I use default expression? Well, that... Okay, so I guess they're saying, yes, I could create one that does create two versions, one that's got the parameter and one that doesn't. Or switch to an existential. I'm not sure what that means. Oh, maybe I gotta make error type an error. No, not getting anywhere with that. Okay, let's do this then. Okay, let's take no error handler. And then implicitly leave it out. And then take an error handler. And just take it. Cannot use default. Inference of error type void. That sounds like it's not caught up. Okay. Now, okay, this is on the test side. Input string. Unable to infer type of closure. Error in the current context. This, well, I'm hoping this builds, but closure parameter error. Cannot convert value of string to expected type EG. Oh, yeah. Exert equal takes an example. Okay, I think we're building. Okay, it does not report an error. Should it report an error? Yes, it should, because this message should be compare the message to the expected value from the example, and that did not compare. Okay. So now this, right, now we got to deal with it. Okay. And so what I'm going to do is return a function. Let's okay, the function is error in error handler of example error. Okay, does that make sense? All right, so we're taking a function of two arguments and we're applying one argument, the passed in one, and the result is a function of one argument, the error. Okay. And I think this test will pass, because it should throw an exception. Yeah, it should I threw, but supposedly we were looking for somebody through. Okay, now the last piece is assert throw succeeds and error is right. Okay, so this one doesn't do that, and this should be I through. Okay, and that assertion should be okay. So this should pass. I should run and pass. All right. Woof. Okay. But good news is we've got that function. All right, we had to do it a little goofy because of the type inference stuff. I wish I understood what they were saying about existential. That's just any. Okay. Yeah, I don't think we had to. All right. Well, good. All right, now let's define this mess. README. EGAssertThrows. You know, I'm going to try changing this order, because we talk about input then expected. So let's put this first. I don't think it should change anything. It's all inferred. Okay. Is that the right name? EGAssertThrowsError. I don't know, there's a better word than expression for that thing. Okay. I don't know if that's enough. I don't know if I'm being quite accurate there. It's really passing the message. Okay, let's take our little test. I think this last one is the best. Okay. All right, I think that's pretty good. Make sure everything's green. Okay, and we'll commit. All right, let's go back here. EGTest that we did. Did I get my number wrong today? Root EGTest. Okay. So we've covered this case. We're going to delete this shortly, but okay. Well, this, we just made up the handler for it. All right, let's go back here. We're going to keep the original. Oh, let's put that back too. Well, good to see it fail. Now we can trust it a little better. All right. I don't think we've done too much there. That's spacing. Okay, next one. Assert actual argument. We did that. Okay, now update EGTest to take a new check with a try. Yeah, so this one, this text lets you call asserts that can throw. Okay, and we'll see if we can pull this in. Let's check. Okay, let's make sure we're allowed to do both those. Pretty sure you can. Okay. All right, and then we'd like to test that one. Let's go back here and see who did it, who used it. Okay, so parse strategy can throw. We'll borrow this. we need a method that could throw but doesn't, so let's put it up there with the other one. Okay, I always throw, I never throw. Type void cannot conform to equatable. What did that used to say? Restrict parse. Well, let's let him. Okay, so this should work. We'll muck with it and make sure it fails if it doesn't. Okay. Why is that working? Assert function would seem to take no arguments. How can I make this mess up? I don't think this will do it. Right. I'm very puzzled why I don't have to pass this argument in. Should run this function. I guess it does pass it here. Well, that's more my test is what I want. Check works with methods that throw. Check works. Okay. So we catch something that fails, and then we want to make one that detects the throw. And I'm not really sure what we're doing in this case. I guess we can make him return something. Nobody's going to look at it. Make them parallel. And I don't know, maybe I got to put them up top. It's a little confusing, I grant you. I mean, we're really wrapping the XCT one, but what it does is if you have an expression that should throw, it will check that it throws, and if you add the handler, you can check that the exact error was thrown. So the first part checks any error, and then this checks the handler. This bit's the tricky bit in a way because it's taking a function of two arguments, an EG and an error, and it turns it into a function of one argument for the benefit of XCT assert throws because it has no idea about example. So, you know, this is kind of a functional trick, I guess you'd say, but you know, you can add and subtract arguments and things like that when you know, in functional languages. Swift's close enough, I guess. We get to define a lambda function with one argument, you know, that handles one with two. So example flows in as a sort of escaping kind of thing, you know, but that's okay. Getting the tests and all that, yeah, that's a bit of a mucky mess, but we're through that. Okay, so this one, I'm really just trying to make sure that if you say throws, that we can detect and handle that properly. Okay, and then now the other change I want to make is I want this to handle, this is brand new, so I can do what I want in effect. I would like to go to a varargs kind of thing. Whoops. I think that's all I got to do. Nope. Well, okay, because you always pass something in anyway. I mean, you pass it as a extra parameter. It's a function. Okay, so now I'm going to break my code, but I don't have to pass in arrays all the time. Okay, where's my complaints? There we go. Right, so this goes away. And notice it's a named argument, but we pass in a closure at the end, trailing closure anyway. Okay, and I want to add this to my regular check too. Yeah. And these should all pass. Okay, no reason to create an array just to peel it apart, right? So, okay. Well, that's good. So we added a check. Well, it's kind of a variadic check that allows functions to throw. Okay, and then I want to do the same thing on our existing one. This one. I guess I don't have to say extension twice. Wait, I haven't documented this one yet. Okay. Okay, and then the next one, again, this is kind of a request. Yeah, this is basically a variadic version of that. And I almost want this to be deprecated, the old one. Like, you don't need to do it. 1, 2, 3. Labeled. Okay. And let's add some tests. This is test check using an array. Not recommended. Okay, so that one, but I want this to work. Okay. And then I'm going to make all these examples use it by default. The only reason you might have it is if you, for whatever reason, you had an array of these things sitting around. Maybe you wanted to define them up top and use the same array in a couple tests or something. Yeah, like this one. Okay. These are not checks. This one. Well, which sort of argues I should support both. Okay, let's make sure these all work. Okay, so I guess I'll do this. They're so similar. can I call this one? Do I want to? Call can throw, but it's not. That's my throws one, yes. Okay. How are we going to document this? I guess you have. Okay, what have we got? I'm afraid to talk. Okay, there we go. All right, run tests. Oh, well, I guess we've been doing things the last couple of days. The week, August 14th. And we've documented it over here. Update EGTest. And not going to worry about this. We did that. Let's move this up. Remove header comments. I think I've done that. Okay. All right, this should have added. Okay, now the part I haven't done for a while. Okay, so we added new functions, but we have not changed any existing ones. I think I'll update to 0.4.0. It's a pretty good release. Okay, now I gotta remember how you do this. All right, take this. And we added periodic check. Assert throws, no, EGAssert equal. And assert, oh, what's the name of that thing? Throws error. Okay. Now, 0.4.0, we should be able to close this project. Oops. I guess I wanted to keep the other one open. I wonder why SF Symbols is in beta for so long here. All right, let's close it this way. Okay. And I'm terrible with libraries, but let's see if we can get this updated. All right. Update package. I'm not sure how that's supposed to go. Where did I have Swift package index? Okay, they got me at 031. I don't know if I have to wait for something here. I don't know if I was supposed to let them know somehow. I don't really see anything that lets me do it. Do you maintain this package? Yes. Okay, we'll have to... I don't know how he knows. If I say add package, I must be able to modify this somehow. Is it on here? This is why I'm not getting this. I must be... How am I managing those? I mean, I can delete and reinstall. Yeah, maybe like... I would think I would have some sort of inspector on here that would tell me. And let's make sure this looks right. Oops. Maybe I've mucked up a GitHub access or something somewhere. Well, that's got our latest. Oops, I gotta... Well, we'll fix documentation, but that seems okay. Tags. Where's my tag? Do I have to publish it on here? Yes. Okay, well... I think I can move that tag, right? So... Oh, I don't have EGTest open anymore. But you have the array form. You space question. Okay. Huh. Some invisible character in there. I don't know if I can. All right, let's push this. Well, let me. Well, I guess we'll make it 0.4.1. Okay, now do I have to push? Okay. I guess this should become done. Okay, that looks good. Where's my tags? Okay, that should release it. Oh, and it updated. All right, now it should have some complaints. Well, because I've got these extensions, I don't need any more. I guess it's redundant, so it's not carrying. Whoops. Yeah. Okay. Okay, so let's take that out. Delete. Okay. And just for safety, we'll do a build. Okay, use updated EGTest. All right, well, that does what I wanted to do for EGTest, so that is cool. I think we are ready to start a new area. All right, well, first we'll take a break, but we'll come back and we'll start this apron pleat idea. So 3 or 4 minutes, and yeah, we're overdue. 3 or 4 minutes and we'll start back. All right, welcome back. Okay, so we're going to start this new area, aprons and pleats. All right, and I don't know, I don't have any. I guess I'll take a piece of paper. When you're making a kilt, you've got the pleats at the back, but there's actually 2 parts that flip over. So I think they call this first piece that flips in is the under apron, and then the apron is the part that really sits in front of you. And the decision is how do you know how big to make the apron or the under apron's the same size, but the apron versus the pleats. You got so much fabric you're going to use. I mean, sort of a default starting place is a third of it is pleats, a third of it is aprons, okay, or 2/3 aprons. All right, so we kind of jumped in the calculator kind of jumped in a weird place. But the first thing was we gave them the capability to compute with inches or feet or yards. In watching my wife work with it, let's see if I can get it running here. Let's start here. So watching her work with it, she hardly ever uses, I don't know if I've ever seen her hit the inch or yard or feet key. But she does use the slash to get those fractions. 5/8, plus 3/4 is 1 3/8. Okay, so for her, that calculation is very important that she can get these things listed in 8ths and 16ths. Okay, we skip forward. Normally in the construction of a kilt, really they start at this apron pleat idea, and they design how much fabric goes for the apron and how much for the pleats in back, okay? And then once you've decided that, you can decide all this stuff that we did on the pleats, it's box pleats or military box pleats or knife pleats and how big and everything there. While doing this work, you need to know the ideal hip measurement for your pleats. Well, that comes from here, this TBD, all right? And the way you're doing it is you basically take 3 measurements. So they measure your waist, which is kind of the narrowest part of you and typically running through your belly button. They measure your hips, which is the kind of across your hips at the biggest point, basically. All right. And then they measure the length from your belly button, well, from where the line of your belly button down to just above your kneecap. Okay. So if you see a kilt and it's hanging below the knees, it's definitely too short or too long. And if it's, above the kneecap, 2 inches above the kneecap or something, it's also messed up. Okay, and so those 3 measurements, what I called actual here, they are you know, that's just sort of the universal thing. If somebody wants to get a kilt made, you know, if you trust the person taking the measurements, then that's what you use. Okay. Now the problems are if you're measuring, somebody has to know how to measure you. Like as you're being measured, you can't look down to see what the person measuring you is doing because it changes your, you know, changes how much body is where. Okay, you have to stare straight ahead. And then you have to actually trust the measurements you get, because what happens is, you know, you get a waist and it says 42 and somebody goes, well, I'm not really a 42, I'm a 38. And it's like, well, you're sitting there with a measuring tape measuring 42 inches. It's like, who are you going to believe, you know? And if you believe them, the kilt's going to come out too small. And usually people underestimate, you know. But at any rate, that's the way it goes. And then there are two questions that they have to ask. And in the proper language, it's, do you have prominent buttocks or a prominent tummy? Okay, so if you think of the old-fashioned look of ladies, you know, with the little padded rear end on their skirt or something to kind of make it poke out a little extra bit. Okay, that's prominent buttocks. If it's prominent tummy, you're thinking of the beer barrel, you know, the beer belly guy, you know. I'm uncomfortably close to being able to demonstrate that live, but you know, the stomach sticking out. Now, if everything's sticking out, it's kind of the same as nothing sticking out. So, you know, it's really for somebody who disproportionately needs more fabric in the back or the front. Most people need a bit in the back, but it's pretty common that they don't. I mean, it's not at all unheard of that they don't. And in some cases, they will actually put like quilt padding in to make the back look a little bigger, so it's a little more attractive that way. You know, if you're too skinny, things just fall off, and it's not necessarily what you want. Okay, so given you have these three measurements, then you don't use them directly. There's actually a stage where you form the ideal measurements, and the ideal is we'll take the waist as is, we'll take the length as is, but the hips, if the waist is greater than the hips. Okay, so Humpty Dumpty, we're going to use the waist as the hip measure, because the skirt's supposed to be kind of what they call, well, not deeply, but A-line. So it's supposed to go down to your widest point and then straight down. And if you've got the hips narrowed in, you know, kind of back to Humpty Dumpty, it's not going to look good. It's going to kind of hang down weird in front. Okay, so they will always adjust the hips to be a little bigger if necessary, okay, if they're too skinny. Okay. Now, when given those numbers, those ideal numbers, you've got to decide how much are you going to put on the apron, the part in front, and how much on the pleats, the folded part in back. And same thing for the hips. Okay, and the process is you start with a 50-50 split. So you assume that half the fabric is going to go, or half the measurement is going to go to the apron and half to the pleats on both hips and waist. And then you are going to adjust from there. And what you're doing is you're moving numbers. Well, basically the two fields, apron, pleats, like for the waist, apron plus pleats should equal ideal waist. Okay, and hips, apron plus pleats should equal ideal hips. Okay. Now, there are a lot of little guidelines and rules, and I'm not sure what we're going to enforce, and I'm not sure what we can, what we'll just treat as kind of a warning or a comment on things. Okay. I think we will probably enforce that apron plus pleats equals the original or the ideal size. Okay, so the waist, you're basically going to try to split it, and you want more than half being used for the pleats. Just in general, it looks better, I guess. You might have as much as 2 or 3 inches difference, but you're not going to have 4 or 5 inches. You're not going to have, like, say you got 40 inches, you start 20/20, and then you say, well, what if I make it 19/21? Or what if I make it 18/22? You know, you try these possibilities, 17/23, but you're not going to go to 16/24. It's too much. Okay. Now, I don't know what we'll enforce. My thought is to enforce to maybe like 4 inches or less, because maybe there's somebody's got a circumstance, but we don't know. All right, so the waist, we want a little bit more in the pleats. Okay, now the hips, we also want more than half or more to the hips. Okay, so we're trying out all these possibilities. So what I've seen people do then is they'll take this table and replicate it 5 or, I don't know, maybe more times, and they'll just try some ideas. What if I made the hip this and the waist that, and just kind of check them, see how it works. And then you might bounce over to the pleat calculator part and say, well, I can't get a 20-inch waist with the fabric I have and everything, but I can get a 21. Okay, well, let's try 21 and see how it works, So there's a little bit of interaction and back and forth there. But the real thing is, I'm thinking just a slider. I was originally thinking of little buttons to go, left or right. Like you click the button and it moves a 1/4 inch from one side to the other. But I think maybe a slider might be the trick. And the slider can go from, minus 3 or 4 to +3 or something, scheduled by 1/4 inches seems to be the level they do this at. The measurement stuff, I've never seen any of them that say something other than a 1/2 inch. You're a 29 or a 29.5 or something, not usually a 29 1/4. I don't, it's certainly possible, and there may be situations that demand it, I guess. All right. Now we're going to get into these guidelines, and this is, I don't know, this is like a wall of business rules, basically. So you want a 3 to 4 inch difference between the waist and the hip. All right. So you want that A shape, so you want the waist to be narrow and the hips wider. Okay. Be sure the apron width at the waist is less than the apron width at the hips. Okay, you definitely want the hips wider. Okay, now you get to the big butt people. Okay, if somebody's got a well, normally we want to choose the hip split 1 inch bigger than the pleat, unless they've got a big butt, and then we're going to want more in back. Okay. You don't want to ever use a 1/2 and 1/2 split, even though that's your starting point, 20/20, say. If the waist and hip are identical, you're gonna make the waist a little smaller and the hip a little bigger. So there's, even if it's just a little tiny bit of a frame kind of thing, but it's there. Okay, double check that apron plus pleats adds up for waist and hips. Yeah, we mentioned that. All right, and then more guidelines. Try for 1 inch more in pleat than apron. I'm not sure if I said that. Yeah, that's number 3 over here, I guess. Okay. If somebody's got a big stomach, okay, beer belly guy, equal apron and pleat splits at the hip, or the pleat only a 1/2 inch bigger. And then the other case that can happen is a large waist hip difference. So, think of the classical, figure 8 woman, very narrow hips, very narrow waist, very relatively wide hips. Or I don't know, maybe this is the anthropology woman, if you really want, you're going to put an extra bit in the pleats. Okay. 1 inch and 1/2 to 2 1/4 inches. Okay. So that's where 1/4 inches come in, because they do deal with that. All right. Now what I've done to research this is I've really dug into one kilt making book, and they had a couple of pages on this, maybe 3 pages, and a couple or 3 pages of examples showing it. So when the time comes, we'll do some examples, but this definitely gets us going. Okay. And so I didn't really sketch out, but what I'm imagining is we'll have a table up top that has those actual and ideal measurements. Oh, sorry, I missed the question. Does the pleats also have changing measures for waist and hips? Yeah, I mean, both sets of boxes, they may adjust. Okay. The constant is apron plus pleat equals ideal. Okay. But, you know, people, there's some amount of adjusting no matter what. And it's kind of like, I mean, what my wife's teacher says is, you know, you could have 10 different people take the identical measurements and the identical tartan and come up with totally different results here. And that's kind of one of the tough things for the beginner kilt makers, is they want to assume like there's a formula, and there is not. There's a tool that lets you make trade-offs, and you know, you get to judge, is that enough? You know, is that enough difference between things, and so on. So all this stuff turns into judgment. And that's why I'm not sure how much, even though it's only 7 or 8 guidelines, like, well, maybe plus 9, 10, 11. But, you know, I'm not sure how much to do, because they really do make judgments on it. I think we can provide some interesting stuff for them to say, you know, oh, this is suspicious, you know, that your waist is bigger than your hip is probably a mistake, you know. But they definitely make judgment calls on this stuff. All right, so let's see, back here. So I'm imagining our ideal table up top, and then a series of sort of scenarios on the bottom, maybe scrollable, I guess, that represent the small table like this. And kind of like our other thing, I'm imagining something will put out some text underneath one of these if there's some problems with it, you know, but every combination they make might have some problem, and they just have to choose. And then I'm also imagining like a selector, or maybe it's one gets a solid star and the rest are hollow, but whichever one you select should show up on the top, and maybe we'll stretch the table. I think they have a table that is, they use a larger table than this that has the answers in it. So I think we'll make that part of the table up top. So at the end, they'll have something that says measured, ideal, and here's the splits I chose. Okay, and there's no length splits. The length is the length. Okay, I don't know if we'll ask these questions, or maybe that becomes a rule, or maybe we just trust them to figure it out. Okay, and we'll see. All right, and then I think that's it. The one thing we might add, it might be nice to go from here to here and have the ideal hip filled in based on the split you did. Okay, so this would be the hip pleat split would show up there. Okay. And I don't think that's too hard. Of course, I don't remember what the state is of tables and grids and whatever's these days, but let's get together. Close this. All right. So, and I don't know where, you know, I go back and forth on where I'm going to start with things. I think we'll start. Well, I guess we know there's some stuff. All right, let's start with a little research. Swift table versus grid. I don't know what they're doing these days. Okay, the grid's kind of this flexible thing. I mean, you make a grid with a bunch of rows. That seems pretty straightforward. I mean, that looks like what we're trying to do. So I'm imagining we'll do it. A grid. But then there's table as well. Grid. Okay, here's table. Okay, rows of data providing the ability to select one or more members. Well, we want to edit more than select. Columns, tables with static rows. Yeah, that's kind of us. Okay. Well, let's start with grid and see where we go. I guess we'll go back here. Okay, so this is constant stuff. You can put dividers. Okay. All right. Where's our apron pleats? We have a view. It says TBD. All right. Let's play with getting some pieces out there. Button to send a measure. Man, that's a good idea. Let me capture that one. Oops. Well, this is really the, I'll say scenarios. I don't know the right word for us, but button to send info to Pleat designer. Yeah, that's nice. All right, so let's do the actual ideal table. Okay, well, grid VStack is right. We're going to put a grid. It's got a row. We'll put a divider. Another grid row. I guess we have 3 rows. Well, already, this looks big, right? So let's extract out something. Okay, so let's call this the measurement table. Yeah, let's call it measurement table. So let's make that thing. New file. I'm trying not to get so far behind on the view getting outgrowing things. Okay. Save view. Okay. And let's just take everything from here. Well, missed one. All right. Measure table. Lost. Okay. This was supposed to be some view. How fast can I mess it up? Okay. Okay, let's unpause this. I can hear my computer winding up. Right. Okay. We want, I guess, just text empty. And then actual. I wonder if as measured might be better. And I'll just put some bold on this. Now, I don't know why it's so wonky looking. Okay. Why are you so weird looking? All right. Now, waist hips length. Whoops, I guess there's 4 grid rows. Okay, that's coming out a little better. The whole thing, let's put a little border on it. And some padding. Oh, I guess I'll put some padding before it too. I don't really need the padding here. It's kind of the collar's job, right? Okay. It's tolerable enough. All right, now, what's the model of this stuff? Well, I guess this is computed. This is copied. This is computed. This is copied. So let's get a measurement thing. I mean, the real thing is your waist, hips, and length measurements, and those need to be they need to be editable. All right, and then the computation comes in such as it is the ideal, and we just apply this rule: waist, gird, and hips use waist, otherwise use measured. You know, it's kind of a modified copy. All right, and then I think Apron Pleat View should show this table now. Yeah. Okay, this version, I don't know, I just needed it at some point to make sure which version I was running. And I don't need TBD as we're starting to get some stuff in here. Okay. And I think here we'll say there's padding. We'll push it up to the top in due time. All right, but I think the thing I need is I need 3 fields, three bits of data that are inches. I don't necessarily have to have them be inches here, but the reality is they are. Okay, and so I guess, is this a struct? I think it's a class with 3 fields. All right, so let's go define that class. Okay, there we go. A new test file. Measurement tests. All right. Okay. I guess derived values. Okay, I don't know. It's old habits, really old habits. Am I going to call this? I guess I'm going to call it actual waste. That is not my actual waste. Actual hips equal 32. Actual length equals, I don't know what they are, typically 25. All right, now if I get those things, missing argument for parameter from. Oh, what should we call this then? Let's call it KiltMeasures. If I do this properly, it actually does work. KiltMeasures. Okay, let's rename this. Oh, I don't need to rename it yet. Okay. Okay, and now assert equal m dot ideal waste is 30. We'll see what we. Yeah, I think that's a starting point. Ideal hips. Ideal length. And ideal may not be the right name, but all right. If your hips are less than your waist, we have a rule. Okay. Let's check our rules. If they're identical, if waist is greater than hips, use this. Okay. Well, I guess we got 3 cases, right? When hips bigger than waist. Okay. We need a class. Let's just put it here for a moment. Now these things well, this is really, I don't know, we haven't derived that, I guess. Okay. And then var ideal waste is actual waste of double. Now, I don't know what we're doing about missing values yet. need to do that. Okay, this test should fail. Oh no, it should, yeah, it should fail. I made some of them pass, but not all of them. Okay, ideal hips. Oh, I should make these the correct answers too, huh? Okay. Try that again. Just the one. Okay, let's make this actual hips. Okay. And let's check our rule. Three cases. Okay, so hips equal waist. Well, that's pretty. I don't know if I should care about these others. Let me structure this a little differently. Let's take, well, let's make this case. Let's get the ones that are always copies. We'll take the hips out of the equation. And now we'll take the length out of the equation. And I only want to look at the hips. Hips smaller than waist. Okay, so hips bigger than waist, 30, 31. We expect 31. When hips equal waist, we expect that, and if they're less, hip value copied when hip bigger than waist. Hip value copied when hip equals waist. Use waist for hips when hips use waist for hips when hips smaller than waist. Okay. Yeah, and we'll all right, the last one should fail. Yep. Okay. And the rule is if waist greater than hips, use waist. And I don't know if it'll let me format this way or change it every time, but I sometimes use this format for a ternary. Actual waist greater than actual hip, use the actual waist, otherwise the hips. Waist greater than hips, use waist, else hips. Okay, this should pass. All right. All right, and then let's make one of our EG tests going. Okay, so function test hip values, and then we're going to do a check. That's funny, it's not ours, but okay. With our EGs and a function. All right, so let's make an example. The input is 30, 31. And just to keep my warning level down, we expect 31. Hip greater than waist. $30. Okay, so we're gonna yeah, let's do this stuff. Unexpected separator. Surprised they don't allow that there. Okay, $0 dot input. Okay, So this is waist hip and ideal hip expected. I'm gonna call this ideal hip. All right. And just to make sure the test is doing something. Should break, I should say. Oh, well, that's a good check, right? I guess I should use my EGAssert. What? Oh, did I not make it public? EGAssert equal. Well, an actual and expected is an EG. Cannot find EGAssert equal. What? This is weird. Is my package not synced? Does this have dependencies? I thought they were all managed in the other thing. Well, source, mention. Oh, this one doesn't care. It's the calc test. Target dependencies, Kilt calc. Link binary with library. Always used required. Oh, did I import EGTest? Good. All right. Yep. And I don't need these anymore. Okay, now let's hook this up. And I guess I'm going to put it here for now. State object measures equals KiltMeasures. Okay, that should complain. Okay, well, that's not quite what I meant, but it requires Kilt measure conform to result observable. All right. Okay, and we need some published fields. Okay, measurement table. Oh, I should put this on measurement table for now. Okay, those are fine. And then this one, the waste row, well, we only have a couple minutes, so I'm going to just kind of make it up. This is actual waste. And his value. Measures dot actual waste. Maybe it's, and then this is text. I'm going to do the same little thing for these two. Hips. Actual hips. I think I missed one in here. Cannot convert value of published double dot publisher to expected type binding of string. Am I doing that backwards? Maybe I do both. Cannot convert value of binding publisher to binding of string. I got to do a numeric thing. It's just format. Now my dollar signs, excessive dollar signs will come back. Don't have Swift UI. Oh, okay, there's a different, it's got a field value colon, yeah. All right. Okay, well, much love some formatting, clearly. But I don't know, we'll have to worry about this nullable aspect of it. Okay. But I think that's a start. All right. Let's stop there. We'll pick up tomorrow, Thursday, 2 to 4:30 Eastern and 6 to 8:30 p.m. UTC. And then tomorrow's it for the week, and then I'm off for 2 weeks. But when I come back, we'll finish this unless we've made incredible progress tomorrow. I don't think we'll quite finish it then, but this is editable and this is not. So, we're making progress. All right. Thanks for joining, and catch you again sometime, I hope. Bye-bye.